Now we will go through the process of implementing RSA encryption. In subsequent videos, we'll go through a toy example and then a real-life example. So before we implement, there's a couple of preliminary matters. If we have a message, which is a text message, then the first thing we need to do is to translate it into a number, just by some simple code. For example, we may let A correspond to the number 01, B to the number 02, C to the number 03, up to Z, the number 26, spaces, perhaps number 27, comma, 28, full stop, 29, and so on. So, for example, if we take this message here, key is under mat, high security message, then that would translate into this number here, W, because K is the 11th letter of the alphabet, E is the 5th letter of the alphabet, 05, Y is the second last letter of the alphabet, so that's 25, and so on. So now we can think of our message M as a number W, or our secret message M as a secret number W. The problem now then is to encrypt the number W rather than the original message M. So very briefly, overview of the RSA method. Bob publishes a special number N, and this number will be unique to Bob. And in fact, what happens in practice, a new number may be generated every minute or two, or even more frequently. And typically, the number N will have 300 digits or more, perhaps 600 digits. And there will be one other number, E, given by Bob, and both of these numbers are made public, and E is not particular Bob, and in fact it's often convenient to take E to be this number here, 2 to the 16 plus 1, which is prime, which is 65,537. Sometimes E will be a prime as small as 3 or 5. Now anyone can use NE to encrypt a secret number W, which is intended for Bob, into another number C, and that number C is going to be made publicly available. Only Bob can decrypt C back into W, and once Bob has W, then it's immediate translation into M. The point is that N itself has two factors, two large prime factors, 150 digits each, maybe up to 300 digits each, and these factors are known only to Bob. And the process of factorising the number N into its two prime constituents is something that is just not feasible computationally. Suppose that somebody has a message, M, which they want to send to Bob. In order to apply the RSA process, it's important that the number W, which comes out of M, is less than N. Now remember that every character during M is replaced by 2 digits. So twice the number of characters in M is the number of digits in W. So if the number of digits in W is less than the number of digits in N, then certainly W is less than N. Just a very simple check that W will be less than N. Now, if W is bigger than N, then we simply split M into smaller blocks so that each block satisfies this simple condition here. Twice the number of characters in M is less than the number of digits in N. Now, if W has many fewer digits than N, for security reasons, what we should do is pad out W with some random junk at the beginning. And an easy way to do that, so that there won't be any confusion what's junk and what's not, is to begin with a 99, because assuming that 99 is not used up here, and to end with 0, because remember we started numbering from 01, not from 00.